On section 5, day 1, what we're going to talk about in your book calls them properties of logarithms. I've also seen it and referred to them as the laws of logarithms. So either way, depending on what book and author you have, like for instance, the college algebra book, we talk about the laws of logarithms. In this book, we talk about the properties. I'm going to call them laws, but your book calls them properties. There are 3 of them, okay, 3 big ones. And here's how they work. The first law states that if you have 2 pieces multiplied together, so if you have an A and a B, okay, so when it says AB there and there is no symbol in between there, that's understood to be multiplication. What happens many times is that you have multiplication between the 2 parts, but you don't know what A and you don't know what B is separately. Okay, or maybe you do know what they are separately, but not when they're multiplied together. So multiplication can be split up or expanded to look like this. The log of A plus the log of B. Now notice one thing. I did not put a base number in there. Okay? Notice how I didn't put a base number in there. So on my problem, it would be understood to be base 10. However, that base could be whatever you wanted it to be or whatever it needed to be. Okay? But for this particular problem, what I'm getting at is when it says AB like that on the left-hand side, it can expand out into addition. Maybe you know each of the pieces, like you know what log A is and log B is separately, but A times B does not work, and you don't know what that is. Okay? So multiplication is the same as addition. Law number 2. If you have A divided by B, let's see if you guys can help me figure this one out. If A times B is equal to log A plus log B, what do you think log A divided by B is going to be? Log A minus log B. Right. So if you look at these 2 laws, multiplication is the same as addition, and division is the same as subtraction. Now, the thing about this is tomorrow we're going to revisit this and we're going to actually condense things, meaning we're going to go from the expanded form, the adding, subtracting stuff, into a nice little itty-bitty package. Okay? The third law that we have is talking about the exponents. If you have something raised to a power like that, so I have log A to the C power, whatever that happens to be, when you're expanding, the exponent goes to the front. So you just put it in front of the log. Now, this is the rules or the laws, properties, whatever you want to call them, that we're going to use today and a little bit tomorrow. All right? So this is we're going to get a lot of practice with this stuff. Now, here's what they're going to have you doing. Everybody got those? Okay. The first set that you're going to be doing is you're going to have something like this. It's going to say log base 2, 3 is approximately 1.585. And log base 2, 7 is approximately 2.807. I want you to evaluate the log base 2, 3/7. Now, when you have 3/7 like that, do you know what the log base 2 of 3/7 is? No, because it doesn't give you that. But it does give you 3 on its own, and it does give you 7 on its own. What is division the same as, according to the laws I just gave you? Subtraction. So what I could do is, knowing the laws, because I have division in there of 3 divided by 7, I could actually go like this and go log base 2, 3 minus the log base 2 of 7. So I've split it into 2 different pieces based on the expansion. Now, do you know what log base 2, 3 is? Yeah, it's on the screen. It's 1.585 minus, do you know what log base 2, 7 is? 2.807. So what am I going to ask you to do is I'm going to ask you to subtract them. What's 1.585 minus 2.807? 1.585 minus 2.807. Negative 1.222. Okay? Now, if I gave you something like this, the log base 221. Again, you have a 3 and a 7. To somehow get 21. So think about it for a second. Hopefully it doesn't take us too much longer than a second. How would I get a 21 if I only have 3 and a 7? Yep. So 3 times 7 is 21. So instead of having it as the number 21, what I'm going to rewrite it as is I'm going to write it as log base 2, 3 times 7. And how is the multiplication expanded? What's multiplication the same as? Addition. Good. So I take the log base 2 of 3 plus the log base 2 of 7. Or in this case, 1.585 plus 2.807. And what's the final answer? 4.392. What do you think so far? Not too bad. What if I give you something like this? It says log base 2, 49. Again, remember, you only have the number 3 and the number 7 in order to get 49. Anybody know how I'm going to do that?
So using the same numbers from
Same numbers from before, yep. Okay, multiply it again.
I'm not sure. Does that look right?
Is it a single digit or a double?
Okay, so Jalen's going to try this one because he really wanted to try it. He thinks he's got it, so. All right, so Jalen, what'd you do?
So I broke down the log squared 49, or the log. I don't really know.
Base 2, 49?
Yeah,
Okay.
yeah. And then I brought the 7 down for the 2 log. It's kind of hard to explain.
How about this? How about I try and you just fill in the blanks, okay?
Yeah.
So what Jalen, I think, did is 49 can be rewritten as 7 squared. Agreed? And so then what happened was Jalen used the third law, and that was the exponent goes to the front. Right? Okay? Then what would happen is he would have taken 2 times whatever I told you log base 27 is, which I think was
2.807.
2.807. So you take 2 times that, and he got 5.614. That's awesome. During first hour today, somebody had said they didn't even think of the squared. They put 7 times 7 instead of that. Could you have done it that way also? Could you have said 49 was 7 times 7 and then split it with adding? And then taken 1 plus itself? Absolutely. That would have worked fine. So the first half of your assignment today is going to be dealing with numbers like this. This is what you're going to do. They're going to give you a thing, 2 different parts, and you have to come up and make it if you can. Then, the next thing that they're going to have you do is expand things like this. The ln of 5x to the 4th over y will go. Now, when I say ln as compared to log, are they the same things? Do the same rules apply? Yes. Because ln, remember, stands for natural log, meaning you're logging the natural number. So therefore, all those laws that we talked about also apply here. Now, when I'm expanding this is how I expand it myself. When I expand it, anytime I have a division like that, division is the same as subtraction. So me personally, I like to get rid of the fractions first whenever possible. Okay? To me, I think it's easier that way. So the next one would be the ln of 5x to the fourth minus the ln of y. So I've taken the division and I've separated it out with subtraction. Now, here's where the next part where a lot of people get it wrong. Not only high school students, but also college students when they do this too. That first part says 5x to the fourth, and what a lot of people do is they put the 4 in the front and they leave it alone and think they got it right, which it's wrong. Here's why. That says the natural log, or the ln of 5 times x to the fourth. How do you get rid of times? Division. No. How do you get rid of times? Addition. Does the 4 power go to the 5? No. Unless it was in parentheses, which it is not. So when it says 5x to the fourth like that, that's really 5 times x to the fourth. So therefore they get split. Now at this time, if there's any exponents, we get rid of them. Is there an exponent on the 5 that you see? No. Is there an exponent for the x? Plus 4 ln of x. Is there an exponent for the y's guy? No. So the ln of y. So then I'm officially done at that moment. Okay? This is the second half of what you're going to be asked to do today, is expand them. What do you think? Okay? Now, if you see anything like this, the ln of 5, the square root of x, is there any division in this problem? No. Okay. Is there multiplication in this problem?
Yes.
Yes. So how do I get rid of multiplication? Add. So I have the ln of 5 plus the ln of the square root of x. What do you think? Not too bad? Now, here's the catch. Is there any exponents in this problem?
Yes.
Yes. There is. The 5 has an exponent, but it's just a 1. Do I need to put a 1 in front of something? No. Does the square root have a exponent? Yes. And this is the part that you guys did in chapter 5, which you probably forgot because it was a couple months ago. The ln of 5 does not change, but this, remember, how can I rewrite the square root of x? X to the, I think I heard somebody say x to the 1/2. Okay, remember, square root, or the radical symbol of square, is equal to a 1/2 power. If there's a 3 in the correct number, which means the cube root, then you'd put it to the 1/3 power, and so on. So how do I get rid of exponents? Where do I put them? I think somebody said in the front. Because they were yawning in the middle of them saying it. And they're doing this. Okay? Does it go in front of the 5? No. What if the 5 would have been underneath with the x? Then would it have? Yes. Then it would have went in the front of both of them, not just the one. So be careful with that. Do you want me to do another expansion like this? Because this is the second half of your assignment. The first half will be numbers. Second half, you've got variables. So, on your stuff today, we're on page 331. Three through 9 odds, 10 through 12, and then 14 to 20 evens.